we were in this one. I think we have solved, isn't it? In the last class,
Yes, sir. We solved it.
I think we were talking about CDF, and then we solved the quiz 3.1, and this quiz 3.1 we have already solved. I think we already solved. We already solved. Have we started the PDF? No, I think
No, sir.
no. Okay. So the thing is, the probability density function PDF is something. Actually, I told you in the last class that in the previous chapter we started with um, PMF, CDF. We started with PMF first. Then we talked about the summation of PMF equal to the CDF, if you can remember. Uh,
Yes, sir.
Now, in this chapter, actually, we will not start. I mean, we have not started with PDF. At first, we have started with CDF. Then we are talking about PDF. Why is it like that? Look at that. In the uh, PDF definition, they are telling that the PDF is dfx by dx. So we are having some fx like this one. Okay, this is the CDF of x, and then that is the x. And then what actually we are doing, we are talking about that the PDF fxx is the dfx divided by dx. What does it mean? It means that this curve is actually something like this, and we are talking about the this value, and that value is the dfx, and that value is the dx. So actually, when I'm talking about dfx by dx, actually we are finding this perpendicular by base, that is actually this tan theta. And we know that the tan theta of this one is the slope of the curve. So at a particular moment when we are talking about the PDF, actually the PDF is the slope of the curve of uh, the CDF. So when I'm talking about uh, at a particular point um, PDF, then actually at the particular point we will see that the dx, if dx goes very small, then actually it becomes almost zero, and that PDF becomes something by zero format, which is undefined. That's why the PDF actually cannot be determined at a particular point by without knowing the CDF. So at first we have to know the CDF, then we have to find out the slope of the CDF curve, and then we will find the PDF. Is it understandable that why actually we haven't started with the PDF?
Yes, sir.
So there is no point PDF. Any point PDF, there is no point PDF. We will talk about a point means that we have to think about this kind of very small distance dx, and that CDF, corresponding CDF. So point PDF means slope at that particular point, and point also we have to think about that this is a very short duration dx. That means short duration or short length dfx by dx. Okay, so this PDF has some properties. First property is, we know that the PDF cannot be negative. It is always more than zero. And then the PDF, a particular point, if I know the PDF value, then at particular point X, the CDF will be summation of all the probabilities before that particular value of X. So this CDF can be found out from the PDF by integrating the probabilities from minus infinity to that particular point X. Okay, so this is the CDF from PDF. Now the thing is, if I'm talking about this integration, if I'm talking about integration from minus infinity to plus infinity, then fx x dx, then what will be the value? This value will be equals to 1,
1.
because I'm taking all the probabilities from minus infinity to plus infinity. Definitely for a particular sample size, when I'm talking about a particular statistical data, then this summation will always be equals to 1. Clear? Now let's talk about this theorem. Theorem 3.3. In this theorem, we actually can see that probability from x1 to x2, that means from this point to this point, this probability means the area under the curve between this point to this point. So this area actually is giving us the probability of this one, and that one can be found out by taking an integration of this curve from this x1 point to x2 point, and that is this area. And remember one thing, this same area can be called by using f x x2 minus fx x1. What does it mean? CDF at point x2. What does it mean? It means before point x2, summation of all the probabilities. Okay, summation of all these probabilities, if I add, that is the fx2. If I'm talking about this one, that what about probability of x fx x1, that will be this probability, this area before point x1. Then if I subtract this fx x2 minus fx x1, actually we will get this area, isn't it? And that area is the that area. So we can say that that is also equals to fx x2 minus fx x1. Is it clear?
Yes, sir.
Okay, that is actually proof already done. So let's solve this quiz 3.2. Okay. Uh, this quiz 3.2 tells, say for example, we are having a probability with some uh, limit x less than x more than equal to 0, and in this limit they are telling to find out the constant c and some other CDF and some probability values. So at first we need to find out the value of c. We know if a PDF is given, that means that PDF from minus infinity to plus infinity equals to 1. That one actually we know. So if we use the known formula, that is integration from minus infinity to plus infinity, this fx x dx, that will be equals to 1. And we know that this minus infinity plus infinity, actually if I use this cx e to the power minus x by 2 dx, actually that limit we can reduce from minus infinity to 0 and then plus infinity. Okay, so if it is like that, then we can take this c out and make the integration from 0 to infinity x e to the power minus x by 2 dx. Okay, so if it is like that, then actually this one actually looks like uv formula, isn't it?
Yes, sir.
I don't want to use this integration. You will find out the integration and find out the result, and you will find out that is equals to 4c. So this 4c will be equals to 1, and then c will be equals to 1 by 4. Okay, So this C value can be calculated from this equation. All right. Now that this PDF now becomes what? This PDF now becomes fxx will be equals to some kind of x by 4 e to the power minus x by 2. This is for x equals to x greater than equal 0, and that's 0 otherwise. Okay. So that is the PDF. That is the PDF from uh, our derivation. Now, when I'm talking about the CDF number 2, when I'm talking about number CDF, then look at this. The CDF we know how to calculate. The CDF calculation is something like minus infinity 2x fx x dx. This is the CDF. Okay. So if it is the CDF, then we can write that for particular our case it is from 0 to x, and we are having already x by 4 e to the power minus x by 2, and that will be equals to 1 by 4 0 to x. This is x e to the power minus x by 2. Again that uv formula, and if you use this one, you can find out. Look at this one. You can find out this. This is the previous one. Second one, if you integrate this one 0 to x, if you integrate this 0 to x, and then this by this like this, so you use the uv formula, and you find out this result. This is the CDF of x. Okay. Now the CDF is actually expressed like this, like the PDF, PMF or PDF. That so this is for one range, and then 0 otherwise. Okay. Now you have found out two answers already. Now how to find the third and fourth one? Look at this third and fourth one. This third and fourth one we can do it easily. Easily means in two ways actually. When I'm talking about probability of x from 0 to 4, and then actually we are talking about integration from 0 to 4 with this um, x by 4 e to the power minus x by 2 dx. And we can integrate, we can put the value, and we can find out the probabilities. Another way is there. What is that? What is that way? Isn't it something like this one? Say this is the curve, and this is 0, and this is 4. Isn't it something like f x 4 minus f x 0?
Yes, sir.
So we can do it like this as well. We have the CDF equation. Just put the value of x equal to 4. We have the CDF equation. Just put the value of x equal to 0. Then you will see that that value actually will be 0, and that value, whatever the value of x4 is, that will be the result. Similarly, number 4 also we can do that. This is, we can say fx2 minus fx minus 2. What is fx minus 2?
Sir, 0.
0. Very good. It is 0 because in the left side of 0, there is no value of PDF. So there is no value of CDF as well. So this fx minus 2 will be 0. So that value also we can find it after putting the value of x equal to 2 in the CDF equation. Is it clear?
Yes, sir. Sir, one question. So we are drawing the CDF curves as well, but in the second question we saw the equation is kind of complex. So how can we draw the curves during exam?
Remember one thing, actually they are drawing the CDF, but actually in the question there is no indication for drawing the CDF. They have just used that CDF. Still, I mean, if it is given in the question like that, then say for example, how can we draw that?
Yes,
Let's
sir.
see. Let's see something like this one. If x equal to 0, it is how much? If x equal to 0, that actually will be equals to 0, isn't it? Look at that. That 1 minus 1 equal to 0.
Oh, yes, sir.
So we have this value. Then we are talking about that that value of actually any kind of curve is possible to draw, isn't it? Because if you put the value of x equal to 1, x equal to 1 value, then you will find 1 minus 3 by 2 into e to the power minus x by 2. X value is 1, so e to the power minus half. You have the calculator, find out e to the power minus half, how much value is this one, and then you can find it out easily.
Okay, sir. So we have to take some random values and
Yes,
find
some
the
random value means
what it.
some values 1, 2, 3, 4, 5, and then you just draw the curve if
Okay,
it is
okay,
needed.
sir.
If it is needed, but I will not try to give it like this because from this one CDF curve calculation or curve drawing is not a good idea.
Okay,
Okay,
sir.
all right.
Yes, sir.
So let's see the next topic. Okay, so this one is the expected value. You can understand in the PMF or in the chapter 2 we use the similar kind of equation for EX, isn't it? Expectation of AX equals to what? X PX summation, isn't it? That is
Yes,
the
sir.
EX. So in this case, now it is continuous random variable. So this continuous random variable case, Px is replaced by Fx, and the summation is replaced by integration. So this is now the equation for this Ex, and we will put the limit from minus infinity to plus infinity because I'm taking all the values. Okay, this is for X random variable. It is true for this Gx as well. Gx is the function of random variable. Okay, so this is the X value, and this is the function of random variable. Okay, so for any random variable X, these are also true. Okay, how it is true? Look at that. First one is expected value of X minus mu X equals to 0. This is what? Deviation from mean. Let's talk about a sample example 1, 2, and 3. These are 3 samples. What is the mean of this value? 2.
2.
So if I'm talking about x minus mu x, that x minus mu x becomes 1 minus 2, that becomes 2 minus 2, that becomes 3 minus 2, and that is actually 1, 0, minus 1. So when I'm talking about expected value of this one, it means again the average. So that will be 1, 0, or sorry, not 1, minus 1. This is plus 1. So minus 1 plus 0 plus 1 equal to 0 divided by something, whatever it is. So that actually becomes 0. So whenever you are talking about deviation from mean, that's expected value, that will be equal to 0. About this particular one, look at this one. Expected value of AX plus B. Normally we know that this can be separated by expected value of AX plus expected value of B. Now this one is a constant value A, so A can be taken outside the expectation. So we can write like this one, and expected value of B. B is not a variable. B is a constant. So the average value of B is also a B. So we can write that this is that one is equals to AEX plus B. Okay. Variance equals to EX square minus mu x square. That proof already we have done, isn't it?
Yes, sir.
Already we have done. So that last proof, variance of ax plus b equals to a square variance of x. If I want to prove it, then variance of ax equals to e of x square minus e of x whole square. We know that. So what is the variance of ax plus b? That should be expected value of ax plus b whole square minus expected value of ax plus b whole square. Do you agree?
Yes, sir.
Equals to what? Equals to, we can write that one. That is a minus here. Minus. Okay. We can write here expected value of a square x square plus b square plus 2abx like this, and then minus expected value of ax plus b whole square. That means we can say a into expected value of x plus b whole square, isn't it? Okay. And that can be written a square e of x square plus b square plus 2ab expected value of x minus aex. Then we can say a square ex square plus b square. Actually, when I'm talking about a minus, I can take this minus in this. I mean, we can delete this one, and we can write a minus over there, isn't it? Can you do that?
Yes, sir.
Yes. So minus 2ab into e of x. We can do that. All right. So that one, look at that. This b square cut, and we can write this 2ab, this 2ab cut. So what is the ultimate result? Result is a square e of x square minus
E of x whole squared.
a square e of x whole square. So if I take the a square common, then it will become e of x square minus e of x whole square. And that actually is what?
A square variance of x.
That is the variance of x. So we can write it here like a square variance of x. And that actually is the right hand side. Okay. So
Yes, sir.
we can prove the fourth one as well. All right. So we can understand that this can be done. All right. Now let's go to the quiz number 3.3. So when I'm talking about the quiz number 3.3, look at this one. We are having this 3y square by 2, and we need to find out, sketch the PDF. Sketch the PDF. I don't need the expected value of y, ey. The fy is given like 3y square by 2. Okay. Now the expected value of y, that will be definitely y into fy integration dy, isn't it? So if
Yes,
it is
sir.
like that, we can do it like y into 3y square by 2, and then integration dy, when the limit can be actually minus infinity to infinity like this, but here, as there is nothing outside, -1 to +1, actually we can ignore the other thing, isn't it?
Yes, sir.
Now if I write this minus 1 to plus 1 and then this 3 by 2 y cube dy, if it is like that, then what can be done? 3 by 2 outside, then this y cube will be y to the power 4 by 4 and then 1 1 minus 1, isn't it? We can write 3 by 8 y to the power 4. We can write directly 1 to the power 4 minus 1 to the power 4, isn't it? That will be equal to what?
0.
0. Okay, that will be equal to 0. Now what about expected value of y square? That will be equals to y square into 3y square by 2 dy integration minus 1 to plus 1. The same equation, just instead of y, we will have y square, isn't it?
Yes, sir.
Then what will be the case? 3 by 2, then integration minus 1 to plus 1, 3y to the power 4 dy, and then that will become 3 by 2.
Sir, you wrote 3 twice.
Oh, yes. So that will be equals to y to the power 5
5 by
by
3.
5. That then will be minus 1 to plus 1. And that will be 3 by 10 into y to the power 5 minus 1 to plus 1 equals to 3 by 10 minus 1 to the power 5 plus 1 to the power 5 minus 1 to the power 5. In this case, look at that. That will be 1. That will be minus 1. Now that will become 2. So it will be 3 by 5, isn't it?
Yes, sir.
Okay. So in this way, actually, we will deal with this kind of things. And then variance of y, we can easily know that that part and this part will be used to do that. 3 by 5 minus 0 is square, isn't it?
Yes, sir.
EY square minus EX whole square. And then standard deviation will be
Root over
root over
variance.
variance. That's it. Is it okay, or I will go for again? And do I need to make you understand again?
No, sir.
Okay. So we are just going to the answer actually 0, 3 by 5, 3 by 5, and 3 by 5. Good. Okay. Now we will talk about these families of continuous random variable. There are 4 families here: uniform random variable, exponential random variable, Erlang random variable, and then Gaussian random variable. Out of these, actually, Gaussian random variable is the most, uh, popular and mostly used actually random variable, because when we are talking about our noise, say for example, I'm sending some information signal like voice, video, or text, and in the channel or in the different blocks, we are having some noise added with the signal. These noise are Gaussian random variable or Gaussian distributed noise. We sometimes call it AWGN, additive wide Gaussian noise. Okay. So these families of continuous random variable. First one is the uniform random variable. Okay. Remember one thing: this uniform random variable. Previously, in the last chapter, we talked about this random variable before, and we have dealt 1 to 6, some kind of things like with 1 by 6. Uh, can you remember this one? That is the
Yes, sir.
discrete uniform random variable, if you can remember. Now we are talking about continuous uniform random variable. So in the continuous uniform random variable, actually you will see similar kind of distribution, just a continuous value. So from 1 to 6, we'll have a continuous value. And remember one thing, this area will be the whole area of the PDF or the probability, and definitely that area should be equals to 1. If this area is equal to 1, actually, then we are having a length. So this one you will say 6. You will see the length equal to 6, and you will see that uh, this height will be something which will make this area equals to 1.
1 by 6.
That should be 1 by 6. Generally, if I say that this one is something like A and B, okay, if this is A and B, then actually the length should be something, some kind of B minus A. Okay, then what should be the height? Actually, remember one thing. In the discrete case, it was 6 and 1. In this case, actually, it will not be 6 and 1. It will be 6 and 0 or something like that. Otherwise, you will not be able to understand the situation. Because 6 minus 1 is not actually equal to 6. So the length is 6. So if the length is B minus A, the height should be what?
1 by B minus A.
1 by B minus A. Very good. So if the height is 1 by B minus A and the length is B minus A, that will make this area equals to 1.
1.
Okay. So this is very important. And remember one thing, from this, look at this one. If I use this three different, characteristics, this one, and this one. First one is the CDF. How the CDF is calculated. Remember one thing. This A and B, before A, if any point X is before A, what is the probability, or what is the CDF at point X?
Sir, 0.
0, because there is no probability before that one. If a point is after B, what is the probability?
1.
1. If it is in between A and B, then how to do that? Remember one thing, that actually is carrying an area like this. So when I'm talking about CDF, actually I need to find out this area. How much is this area? Look at the length of the area. If this is the X and this is A, that length has to be how much? X minus A, isn't it?
Yes,
What
sir.
is the height? Height is already calculated. It is 1 by B minus A. So the area will be X minus A into 1 by B minus A. So you will find the area like X minus A divided by B minus A. So that's what they are telling, that look at their thing. Their thing is the CDF is between this range is X minus A divided by B minus A. That is the area of the particular um, area before point X, when the X is between A and B. Clear? Now
Yes, sir.
now this E of X is actually B plus A by 2. We can easily understand average value of A and B because it is a uniform distribution. So whatever A plus B by 2, that is the average value. And the variance value is actually also b minus a square divided by 12. Actually, we need to find out this variance. How to find the variance? We know already. E of x square minus e of x whole square. So e of x already we know, b plus a by 2. We need to find out the e of x square. And that is what? X square into fx integration. Isn't it? Like
Yes,
x
sir.
square into fx means what? 1 by b minus a integration dx. Then what will the 1 by b minus will come in front, and then integration from minus infinity to what? Um, to what?
So to x.
Not to x, to plus infinity. Because we need to find out when I'm talking about e of x, we had taken all the values of x. So in the case of x square as well, we'll take all the values of x. So if it is like that, then it is um, x square dx. Now the thing is, it is 1 by b minus a. Now this infinity to infinity, I mean, we can take it from this a to b, because below a there is nothing and above b there is nothing. So we will write it x square dx, isn't it? So if we talk about deleting this, then we can see that this x square can be what? X cubed by 3, isn't it? So
Yes, sir.
1 by b minus a, x is x cubed by 3, and then we are talking about something like a to b, and then we can write something like a b minus, um, or we can say like 1 by b minus a, and then it is 3 in front, x cube. If it is x cube, that means what?
B cube
B
minus a
cube
cube.
minus a cube. Okay, and b cube minus a cube is what?
Sir,
um,
b minus a into b square minus ab plus a square.
b minus a into I think there is a formula that a minus b into there is a formula like that. There is a formula. Mm, what is the formula? A minus b cube equals to a minus b into, say for example, a minus b square. If it is like that, um,
Sir, it's b square plus ab plus a square multiplied by
that
b
is
minus a.
no, that is true. That is true. But I am thinking a different thing. Thinking a different thing. Okay, okay. We can maybe think about it in a different way. Huh? Is it b cube minus a cube or b minus a whole cube?
Sir, it's b cube minus a cube.
B cube minus a cube. Okay. If it is b cube minus a cube, then what? Have we done any mistake? 1 by b minus a. Maybe we have done a mistake before. Okay, no problem. This is actually the x square, isn't it? This is x square. Okay, no problem. No problem. So that one is b cube minus a cube. Okay, b cube minus a cube. That one is b cube minus a cube divided by b minus a to 1 by 3. Okay, that one is expected value of x square, isn't it? All right.
Yes, sir.
So if it is like that, then what about this variance of x? Variance of x equals to expected value of x square minus expected value of x whole square. That is 1 by 3 b cube minus a cube divided by b minus a minus, that is square, b plus a square by 4, isn't it?
Yes, sir.
Okay. So if it is like that, then let's take it something like this one. 12. We are getting 12. So I'm happy about that one. So we are taking also b minus a, b minus a. That one is b cube minus a cube and 4 multiplied by, isn't it? 4b cube minus 4a cube, isn't it?
Yes, sir.
Okay. Try to find my mistake. Okay. Minus. Then we're talking about 3 into b minus a minus 3 into b minus a into b plus a square. All right. Okay. It's getting very complex. Okay. Now I'm omitting this one. All right. Let's check it. Huh. So it is becoming now equals to 12 into b minus a, 4b cube minus 4a cube minus b plus a whole square equal to, say for example, this is uh, 3 into b minus a into a square plus 2ab plus b square. Say for example, it is like that. Or we can do that b square minus a square into b plus a. We can do that as well. Okay, let's go for complex thing, complex calculation. Where is this one? Have we done any mistake? Hopefully not. Okay, now let's it's a long calculation, so there can be mistake in many steps. So 4b cube minus 4a cube minus 3 into actually we have done one long step. We should not have done that one. Actually a plus b whole square into b minus a, b minus a into a plus b whole square. We could have written it like b square minus a square into a plus b, isn't it?
Yes, sir.
That one would be better without, I mean, that one would be ab square plus b cube minus a cube minus a square b. So let's write it here. Okay, so minus 3ab square, then minus 3b cube, then plus 3a cube, and then plus 3a square b. Is it right? I'm just multiplying 3 with this one, minus 3 with this one.
Yes, sir.
Is it okay?
Yes, sir. Sir, I think from this point we can write b minus a whole cube.
Can we write this one?
So it looks like that.
If,
So
if you
4b
can write
cube.
it, then we have already done it. Let's see.
Uh,
12 into b minus a. Okay, let's see what actually it is. This is 4b cube minus 3b cube, 1b cube, minus 4a cube plus 3a cube minus a cube, minus 3ab square plus 3a square b. Very good. So we can write it b minus a whole cube, isn't it?
Yes, sir.
I think we have proved it. I think we have solved it. Okay. So we have solved it. I think this is b minus a whole cube and then divided by 12 into b
B
minus.
minus A.
So we can easily write b minus a whole square divided by 12, which is this one. Okay.
Yes, sir.
So I
Yes, sir.
think we have proved it, but I don't know how. I mean, we have somehow we have proved it. Okay. So go by the rule, go by the formula. Ultimately, hopefully, you'll get it. All right. So any question regarding this proof?
No, sir.
Okay. So let's clear. I'm clearing. Clear all drawing, and then we go for the next one. Exponential random variable. And remember one thing: the exponential random variable is something which actually is a exponentially decaying function. Look at this one: exponential decaying function, and this exponential decaying function is something like lambda e to the power minus lambda x. Okay, so when I'm talking about this PDF, actually we need to talk about these three formulas as well, like this CDF, E of x, variance of x. How we can find out the CDF? We know that the CDF can be found out from minus infinity to x fx dx. What is fx? Lambda into the power minus lambda x dx. Okay, so when I'm talking about this one, actually it is more than 0, so there is no need of minus infinity. We can write it more than 0, and that lambda can be outside e to the power minus lambda x dx, and we can easily say that this lambda and that e to the power minus x means what? That will remain e to the power minus x with a minus lambda 1 by minus lambda, isn't it?
Yes, sir.
Minus 1 by lambda, and then this 0 to x, like this one. So that will cut, and I will get a minus of e to the power minus lambda x with the 0 to x. And if you put the value with a minus, then you will see e to the power minus lambda x minus e to the power 0 means 1. And then if I go to changing the sign, it will become 1 minus e to the power minus lambda x. And that is this one. Okay.
Yes, sir.
This CDF can also be done like this. So all these things can be proved. Ex, variance of x. We just follow the rules. Ex x fx dx integration like this, and then x square, then variance will be ex square minus ex whole square. We can do it, isn't it?
Yes, sir.
We can do it. All right. Then remember one thing. Then the next one is the Erlang random variable. Remember one thing: in the Erlang random variable, this is actually similar to the exponential random variable. Look at this n. If you put the n value equals to 1, then you will see that the Erlang become the exponential. Okay, this Erlang becomes the exponential. So you can check the lambda to the power 1, x to the power 1 minus 1 minus 0, e to the power minus lambda x divided by factorial 1 minus 1. That means equal to lambda to the power e to the power minus lambda x, and that is factorial 0 means 1. Okay, so this Erlang random variable is another kind of random variable with a form like this one, and it is a kind of n dimensional exponential random variable, and we can use it, and definitely we can find our exponential value as well as the variance value if we use like this from the previous one. And you can see that this n value equals to 1 means they are actually converging to exponential random variable exponent ex and variance of x. So if you use that one, you can find out the expected value of x equal to this one and variance of x equal to this one. Okay, you can do it. Then comes the very important one, which is the Gaussian random variable. Okay, the Gaussian random variable is something where we are having this fx equals to 1 by root over 2 pi sigma square e to the power minus x minus mu whole square divided by 2 sigma square. Okay, so here remember one thing, this mu is the mean and sigma square is the variance and sigma is the standard deviation. Okay, so mu is the mean and sigma square is the variance, where sigma is the standard deviation. And this standard deviation, if you just see the theorem, and you will see that this standard deviation and mean, they are actually responsible about the curve of the Gaussian distribution. The Gaussian distribution curve is something like a bell-shaped curve with a mean about this mu and variance with something like this one. The more the value of variance, the more flat they are, because from the Gaussian distribution we know that 67% data is remaining with +1 -1 standard deviation of that particular Gaussian distribution. So if the standard deviation is more, that means definitely it has to be flat to maintain that ratio. What about +2 -2 standard deviation? Within +2 -2, there are 97% data possible. And within +-3 standard deviation, 99.9% data is there. Okay, so look at this. This is a Gaussian distribution with mu value equal to 2 and sigma value equals to half. This is the similar kind of Gaussian distribution where the mean value is same, but the standard deviation is 2. So as the standard deviation is 2, actually it actually has to be flat to maintain this kind of standard. Okay, so if we use this Gaussian distribution, we'll see that whether it is becoming I mean narrow or flat or steeper or flat, that depends on the value of this variance. Okay, remember one thing, this value of the variance actually we'll talk in the next class, but still I want to see this just a moment, that standard normal random variable, this is a very important thing. When the mu value is equal to 0 and the standard deviation or the variance value equals to 1. Okay, so when we are talking about a standard normal distribution, then we are talking about a Gaussian distribution with mean value equal to 0 and standard deviation equals to 1. Okay, so I want to keep the lecture within this particular topic in the next class, because the standard normal distribution will need some extra care and extra examples. So in the next class we will start with this standard normal random variable, and then we will try to finalize, or we will try to finish our chapter 3, inshallah. So you have your class on Saturday, so hopefully we will have the class, and inshallah we will finish chapter 3 on that particular day. And remember that our mid exam will contain chapter 1, 2, 3. So even if we are lacking of 1 or 2 slides, you have to read it by your own. So in the next class, inshallah, hopefully we will finish chapter 3. We are actually in the, I think, 26 or 27 slide, and we have almost 36 slides, something like that. So I think it will not be a problem. So if you have any question, you can ask.
Sir, for mid, we have to learn the derivations, right?
Everything, everything. Because in the mid, it is not like the Google form quiz. In the mid exam, there will be a written exam. So in the written exam, any kind of question can come. It's like the mid exam of your, um, face-to-face class. So there will be problems, there will be derivations, there will be definitions, all kinds of things will be there.
Okay, sir, going through previous year's questions, sir, should it be enough for
And not enough,
no
definitely not
question
enough,
pattern?
definitely not
Okay, sir.
enough, because online and offline are different. Uh,
Okay, sir.
Previous year questions was not enough on the offline case also, but for online case it will be different. In the previous years, actually there were some common questions, uh, and we will let you write the common questions by your own. But now if we do that, actually you will have the answer in front of you, and you can just see and write. So the thing is, the question a bit will be different, but still, say for example, definitions, or say derivations. Say for example, I'm giving one derivation which is not in the book. So you have to derive in the in the classroom, or in the um, spot. Uh, so questions will be a bit different than the previous questions. But remember one thing: we will try to give some questions which will actually test the students, for different kinds of uh, students. Different kinds of questions will come. There will be some questions which will be easy, and there will be some questions which will be very tough. So prepare like this. Any other questions? So hopefully there is no other questions. So I want to thank you today, because I don't want to give attendance today. Okay.